Select the value equal to -4 volts. Here we will continuously add new charges. Here we will remove appearing charges as long as the potential difference is maintained. In the 19th century, current direction was considered as the movement of positive particles. However, in the 20th century, it was discovered that charge carriers are electrons. A rule for the movement of positively charged particles was preserved because it's indeed more convenient. Therefore, instead of electrons, we will use positively charged particles. The potential created by positive charges is recorded with a plus sign. In fact, the direction of current is only important for calculations, and we will consider it a bit later. Of course, there are situations when both potentials are not zero. What do you think is the direction of electric current? Not quite right. In fact, current always flows from higher potential to lower potential. By changing the potential values, you can observe how the potentials affect charge movement. It's important to emphasize that it is the potential difference that affects the direction and intensity of charge movement. Another parameter affecting the intensity of charge movement is electric resistance. The greater the resistance, the more restricted the movement of charges. Soon we will take a closer look at how and why resistance restricts the movement of charges. Electric resistance is denoted by the symbol R and is measured in ohms. You can independently see how resistance affects the electric current. Let's denote the current strength and set the direction from a higher potential to a lower one. Now we can determine the value of the current strength. We have already determined that the current strength depends on the potential difference and also resistance, which limits the movement of charges. This formula describes Ohm's law for a circuit segment. Current is measured in amperes in honor of the French scientist André-Marie Ampère. Now we know the current strength at this section of the circuit. What do you think is the value of the current at this section of the conductor? Absolutely correct. The same current flows throughout the entire conductor. Of course, the same current flows through the light bulb. Ammeters are used to measure current strength. The ammeters connected in series in the circuit so that the current flows directly through